Hi everyone, this is Ahmad Haider, and I'll be
Hello
I'll be a speaker today
Hi everyone. This is Ahmad.
in terms of presenting uh, my topic about implementing data science. So let's start with a quick background. I'll try to cover this in about 15 to 17 minutes, and we'll keep the last few minutes for Q&A. And if I can't cover your Q&A, my contact information is provided at the end of the slide. You can definitely take a look at it, and you can definitely send your questions to me by emails, and I'll do my best to answer them. You can also look me up on LinkedIn, and that works as well. So let's get started. So let's start with about me. So I am I'm a senior director for data and analytics architecture at Vertex, and I have a background from Georgia Tech where I've done a PhD, and I have a bachelor's from IIT Kharagpur. My experience is in machine learning, artificial intelligence, enterprise architecture, and I have given a keynote on building an end-to-end data science platform and a data science practice. And I've given that keynote at AWS Summit in 2019. You can look that up on YouTube as well. And one of my core beliefs is creating data science at industrial scale, which I think is still not being fully implemented, something that would really be beneficial to each and every organization, whether small or big, in terms of data science at industrial scale. And that's what my fundamental belief is also the topic for today's discussion. So let's go into it. So let's start with some of the challenges, the current challenges that organizations face, right? And that will essentially lead us to why do we need industrial data science and how do we do it? So, in my mind, there are like three types of challenges. We have technical challenges, strategic challenges. And this might be well known to most of you, but I'll just take a minute to just walk through some of them and describe them as well. So, from a technical standpoint, we know very well that it's very hard to hire good data science talent, good data science management talent as well. And when we have the talent and when we want to build this data science models, AI models, etc., we find that many a times there is not enough technical infrastructure in terms of using big data. So there is space and memory constraints essentially. And then the third is, which is very prevalent, is the data quality itself is not up to the standard where you can build a model. So it could be because of the data not being brought in or stored very well, or it could just be because of process variabilities itself. Then there are operational challenges, and by operational I mean what does it take to take a data science with model which has been built, let's say on a laptop, and put it to production on a platform so that can be used regularly to drive some prediction and ultimately a business insight. So, in my experience, some of the things that I've found is there is no proper deployment platform, and essentially it's deployed kind of haphazardly, or there is no IT support structure in terms of DevOps support structure, in terms of support structure for dedicated to machine learning, or in terms of data privacy support structure or something. And it takes a lot of hodgepodge work to be able to put it together. And the third piece is around the lack of data or data available in multiple systems. So what that means is either you have data for machine learning, historical data, but when you want to actually get data in real time or non-real time for predictions, you just find that the data is not at the same quality or the same level that you can use for predictions, or that the data is present in multiple systems in your organization, and to harmonize it is really, really challenging. And finally, the security and access to the systems itself is challenging. And finally, from a strategic point of view, and this is the most important one, I think there is a consistent over or underestimation of what data science can do for you. Many people overestimate, they don't understand the basic blocks, what needs for data science capability to be fully functional. And some people underestimate and they underinvest. The second thing that I notice is the data strategy many times is not connected to your business strategy, which means that we want to create a model, but we don't have an ROI measurement process in place. So we cannot really say how is that particular model going to drive my revenues, going to lower my costs, going to increase my capacity, any of those questions. So those are some of the challenges that organizations currently face in terms of technical, operational, and this is what leads them to not be able to have this end-to-end industrial scale data science. So to solve them, essentially, there are many ways, but I'm on a 20,000 foot level. I believe that there are three pieces that leads to the solution, and combination of these three definitely helps to plug a lot of these components. So this is process, people, and culture. So what do I mean by each of these? So by process, what I'm talking about is we need to have a set process, a set infrastructure, a dedicated set of machines to be able to say that we are going to execute data science and this is how it's going to happen. So here are some examples. For example, depending on your organization, there should be a process like if it's a very mature organization and they have a lot of talent, then an on-premises model may work really well. Versus if it's a new organization, then working on a cloud model works very well when you can ramp up without hiring a lot of talent to basically maintain your infrastructure. That's one example. The second example is just investment in infrastructure. So there should be an infrastructure, for example, a data science platform where multiple data scientists can come in, share the data privacy, share the data engineering tools, share the machine learning tools to be able to build their models, do experiments on a scalable basis and a repeatable basis. There should be a way to report those results consistently so that you're not sharing them via Excels and PowerPoints. Somebody can come in and look at it on demand. And that's the kind of process that kind increases enthusiasm, removes a lot of these bottlenecks in terms of understanding what data science really means and what outputs do you get. And that's where I think really we can start driving some of these process improvements. And I'll take a few use cases after this to explain what I mean. On the people side, this thing is fairly clear. I think there needs to be dedicated data science teams. There needs to be dedicated or clear stakeholders, clear partner relationships. So by that, what I mean is whenever you have a data science model that you built and you want to deploy it, those almost never work in isolation. You take that, you embed it in a business process, which means that the results of the model are going to be used by somebody else who's not a data scientist, as in did not actually build the model. So you have to have very clear expectations with your stakeholders and partners saying that how is the model going to be used, what process changes required, what decision changes are required so that you can effectively use your data science skills. So that needs to be very clearly defined, and those people essentially need to be very well tied into the entire industrialization of data science concept. And the other piece in here which I mentioned is C-suite support. I have personally found that really helps to move along a case, and by that what I mean is essentially executive sponsorship. So when you have executive sponsorship, what you find is you tackle on projects that can effectively influence the bottom line of the company. That also allows you to, when you also have executive support, which means that the executives understand what can really be done and cannot really be done in terms of where the organization's maturity currently is. For example, if I have two cases where I want to, let's say, create a go into finance and I want to create something like a very natural language generation process to identify, create reports, ask questions of my financial team, and so on to tell me if my revenues are declining, what is the exact cause of my revenue decline without actually going and querying in the data. That can be done by data science, but for that, first your financial data must be in order. So executives understand that what maturity is of my data is and what data sciences cases should I even pursue, where can I get funding. And lastly, from a culture standpoint, it's very important all my data science problems should be linked to a business strategy. It should solve a business problem. If it's not solving a business problem and if it's orphaned, in 80 to 90% of cases, you would not really see the value of data science coming to the organization. And the other piece is, I have noticed most places data science kicks off as part for transformation, which is digital or data driven transformation, which means there is a requirement to improve a business process, improve a customer experience process, improve a sales process, and that is basically driven by the volume of data that you currently hold. And it should be a transformation process, which means you need to bring in new thought processes into the picture, new opinions into the picture, and you need to change the way that you're working. So those three really combine to give you a really, to give you this industrial data science experience. So I'll give you two examples here. One, and both of them are my experiences in working in some of my previous companies into how we were able to do that. So the first example is from healthcare. So in this case, the context is that the company wanted to increase the revenues and the productivity of its claim auditing operation using analytics and data science. And so to do this, they were here are what the solution components, specific solution components from a 5 foot level looks like. So the very first thing was we set very clear benchmarks for outcomes, as in essentially what is the revenue target that we are hoping to achieve, what is the productivity percentage that we are hoping to achieve, by what time are we hoping to achieve it, what is the essentially what are we willing to sacrifice in the process, who are the teams that are essentially going to do this, who are the stakeholder teams, who are the partner teams. So we very clearly established those benchmarks. Then we knew that data is the key, so we created a data lake to consolidate all the relevant claims data. This goes into a process piece. We created a analytics center of excellence to basically house all the data and the analytics talent so that we can essentially create these models, create support structure, and do that repeatedly. That comes into a people bucket. We created an enterprise analytics platform which can run these machine learning models at scale. It can basically take in large volumes of data, churn this, identify the best results, figure out precision recall, and figure out which are the best model results that should go to an auditor for review. So that basically comes again into a process. We built new audit workflows to improve productivity, and these new audit workflows helps you to improve your decision making process compared to what was being done earlier. We updated the decision making process as well very clearly by making it run on probabilities versus binary outcomes. What that allows you to do is if you run on probabilities versus yes no outcomes, you get a large volume of decision opportunities and you get more, I would say, capacity. You can increase your capacity because let's say if you have 20 claims and you have to look at them from a yes no perspective, whether it's a revenue making or not a revenue making, versus you get probability like 70% revenue, 80% revenue, 50% revenue, you can take more claims into revenue making opportunities than not so. And lastly, we had a clear C-suite support, which really helped in terms of setting all of these up. So here's an example where industrial data science was established using some of those components. The second example that I have would be from manufacturing. So in this case, the company wanted to leverage its customer and its product data to enhance the customer experience journey. And they wanted to use data science to do it. So in this case, the solution components are relatively same, but a little bit pivoted. Depends on the company, depends on the maturity of the organization, depends on the business that they are in, and so on. So in this case, the company did not have as much talent in terms of data science, DevOps to begin with. So they leveraged cloud native technologies, AWS, for rapid ramp up, which really helped. Then, since there was not already already an in-house talent, so they built analytics center of excellence and cloud center of excellence to support both analytics and cloud, since cloud was a key activity in terms of ramping up. Set up clear sponsorship pipelines, as in what projects would come into this, what projects wouldn't. Set up clear governance process saying who can approve at what level of projects, what projects go to a executive approval, what projects can be approved at a lower level, what are key projects versus what are not so much key projects, and so on. Then we built a cloud native data science platform to ingest, process, analyze, and distribute data, which is the infrastructure. And then once we had that, then we built many machine learning use cases to basically understand customer loyalty, customer churn, e-commerce engines, and a bunch of like 6, 7 use cases, which were built very rapidly within like a 7 to 8 month time frame to help you get over that hump and get started. Since there was GDPR involved in terms of data, then we built new privacy features to secure the customer data, and that goes a lot in terms of making sure that the customers are happy when you're using their data. We build new digital portals to expose the solutions to customers, which goes into your updated processes. You update the process to make sure that now your results can be consumed by somebody else. So we work with stakeholders and digital teams to create the digital portals as well. And finally, we set up agile and PI processes to track the success of these. And with the help of these, we were always able to innovate and improve upon our work that we are doing so that we can create a cycle. And lastly, I have a couple of slides where I give you a flavor of the data science platform that we established. I'm not going to focus on this slide. I have a link at the bottom, which is basically a YouTube link where I talk about this data science platform at length. You can go take a look at it. You can search by my name on YouTube and you'll find it as well. And lastly, some of the takeaways. So, in terms of takeaways, I have just a few. I think the first one is make sure your machine learning models tie to your business context. They provide a direct or indirect impact. Direct impact is what are your business outcome, revenue, savings, capacity, people. Either they're affecting directly or you have a knob, which is an indirect impact, which can tune those direct values. You make sure that communication is really important. So communication across stakeholders is key. I cannot stress this enough. So between data science, data engineering, product, operations, they should be talking to each other. They should be talking to each other every day, every week, every month for what their ideas are and how they are going to implement it. Thirdly, you should know what is your data and what models you're building, especially know its limitation. Know the data limitations, as in what data limitations you have in terms of its business context, in terms of data sufficiency, in terms of data cleanliness, because that will drive what your model can or cannot do and will drive the expectations. Fourthly, pay very, very close attention to data security and privacy. And this is more so now than it was true maybe 2 years earlier, as an example. It's, I mean, with all these, with the PHI data in place, with the GDPR policies in place, with the California Privacy Act in place, there are more and more things coming up in this space, and you will realize that you cannot use the data as freely as you could use it 2 years ago. So pay more and more attention to this if you want your data science to scale. Then we should build data and output traceability from day one. We definitely need it when things go wrong, and they always will. You want to not spend a lot of time digging what went wrong. You want to quickly identify and quickly fix. And finally, when the time is right, create a COE. Bring all the talent together in one place. It creates a team culture. It creates an environment for learning and creates an environment for expounding that learning within the organization. It can be a centralized, decentralized structure, big or small organization, doesn't matter, but create one at some point. So I'll stop at this point. And I know I don't have a lot of time in terms of Q&A. I can quickly go in and see what I can answer. So there's a question on a sense of timeline on Kickstart use cases. So typically it takes about, I mean, from the time that you have your, I would say, decision taken by an executive committee that we want to start to when you have the first model in place with infrastructure, maybe I would say 3 to 4 months, you can get started. But I mean, this is not industrial scale. You have kickstarted. You take maybe like 4 to 5 months to basically make it industrial scale, every process streamlined. And that's when you can go in and get it more and more industrialized. So I know we are at the end of our time. Feel free to send me your questions. You have my contact information here. I'll be happy to hear from you. Take care. Bye, guys.